Anyway, thank you so much for attending my class today. Today is the 8th of December. We are going to continue with chapter 3.2. In the last chapter, we have talked about process management. We have also addressed what is a process, what is a program. Okay, we have talked about process state, new, ready, running, waiting, terminate. We have also addressed the process control block. What is process control block and what are those things inside process control block? Okay, so today we will continue our lecture with chapter 3.2, whereby we are going to look at what is memory. Okay, we are going to understand, we are going to look at what is memory and how is memory being looked at inside an operating system. Okay, so I hope all of you are there, ready, and just share my slides. Okay, all right, so today, inshallah, we are going to do about memory management. So by the end of this section, we hope that you are able to understand what is memory all about, what are the types of memory, and how is the data kept inside each memory, and how does the operating system access these memories. Okay, all right, so what is memory? We start with the basic concept. What is memory? Memory is what we say as a central operation for a modern computer system. Refers to the physical devices used to store programs. Okay, so it's actually a hardware whereby we can store data, we can store programs inside it. And basically, there are two types of memory. One is the permanent version, one is the temporary version. The temporary version is your RAM, and the permanent version is your ROM, your hard disk. These are all permanent versions. So there are two types of RAM. One is the primary version and the secondary version. Okay, the main difference between the primary version and the secondary version is the secondary version data is much more bigger. It can keep more data as compared to the primary version. The primary version is smaller in keeping the number of data and is much more faster as compared to secondary memory. Why is the primary memory faster? Because it is closer, it is smaller, and it's closer to the CPU, okay, as compared to the secondary memory. Yes, secondary memory these days are faster, but as compared to the primary memory, it's way much slower, although its capacity is 100 times bigger or 200 times bigger than the memory size. Okay, so main memory can also be referred to your RAM. Okay, RAM, these are the levels of memory. Main memory is what we say is volatile, meaning to say the data will disappear once you off your PC, as compared to secondary memory, the data will remain inside the computer system even when you off your PC. So it's known as a non-volatile. And is much more slower and cheaper as compared to the main memory. Okay. All right. So in the main memory or RAM, there are data. The size is very limited. Okay. So when the size is limited, okay, not all programs can be stored inside the main memory. You have to remember, any process or any program that needs to be run inside the computer system needs to keep its file inside the main memory. However, the main memory size is limited. So that is why only those important files are kept inside the location of the main memory, right? The remaining of the files are kept inside the hard disk, and there is an area which is called the overlay area, whereby only those important files about the process are kept inside here. If the CPU needs more files, then this overlay area will be replaced by another set of files which corresponds to the specific process. Okay, so dia dalam RAM, the top part or the lowest memory point, because the address is lower there, is always for the operating system. Okay, that is by default. Yang bawah tu, okay, the overlay area are those important files which are changing all the time. Okay, so when the CPU needs a specific file, it refers to the RAM. And kalau file tu tak ada dalam RAM, the file is inside the hard disk. So that is how the flow goes. But the CPU does not know where the file is. So what the CPU does is the CPU will give out something which is called a logical address. So this logical address will be checked inside the RAM to find out kat mana file tu located. So this logical address will be converted back into a physical address, and this physical address is the location of that particular file of interest. So the CPU gives out the logical address. The logical address is now converted into physical address, and this physical address is going to locate where the particular file is. Students might ask me, why do you need a logical address, sedangkan you nak cari physical address? Simply because the logical address, okay, simply because there is a hierarchy. Okay, the hierarchy starts from the registers, which is at the top inside the CPU, the cache memory, and the primary memory, and then the secondary memory. So this is how it looks like. Okay, this is how it looks like. So inside the CPU, there are registers and cache memory. Okay, but the CPU wants something else. It wants another file. So that file is located at the secondary memory, way down here. So that's why the CPU comes up with a logical address, which is checked by the memory, the check, and that logical address will be changed into a physical address, goes inside the secondary memory. Okay, to find out what is that file all about. Okay, so now what is virtual memory, VMS? Certain times your memory is full. Okay, so when your memory is full, the computer system needs more space, so it will automatically take some part of the hard disk and make it inside a memory, okay, and change it into a RAM. Okay, that is why I drew here. Ini memory, ni RAM awak, and there is an additional space kat sini, which is called virtual memory. And where is it? It's actually from your hard disk. So, you ambil sikit from your hard disk and make it as if it was a RAM. Okay. What if you want to support programs that require more memory than what is available in the system? So it requires more. Okay. Kalau tak cukup, then this virtual memory will come. All right. So virtual memory, sometimes we can say you pretend the location is just to pretend that it's memory, tapi actually it's just a hard disk. So this is the hierarchy. The smallest memory is the register. This two is actually inside the CPU. Memory kat sini. This is your RAM, and this can be your hard disk. And there's also another hard disk, which is the secondary memory. So this is how the hierarchy goes. Okay. So memory management. What is memory management actually? Memory management is the process in which memories are divided. Okay, dalam memory itu, dalam RAM itu is divided according to size, because okay, the size of the memory is not big, so the size will be divided according to the number of process, the size of the process, and operating system's job is to make sure all of these memories are in the RAM or inside the virtual memory or inside the physical memory. And if the CPU needs it, the operating system will go and look for this particular file of interest. Okay. Okay. So inside memory management, okay, when we talk about memory, the process, since memory itu kecil, it's only limited size, limited, so only certain files dia boleh masuk. Okay, so the process automatically will be broken into pieces. Dia akan bahagikan pieces dia. Alright, so it's basically like this. Okay, it's basically like this. Okay, it will be broken down into several pieces, and those pieces dia akan masuk ke dalam your RAM. Okay, so banyak mana dia boleh masuk dalam RAM depends on the size, depends on the location, and depends on how much can masuk dalam RAM. Okay, so dia akan masuk in two methods, contiguous and non-contiguous. Contiguous means proses yang masuk tu, pecahan-pecahan tu is side by side, or in a single partition or multiple partition. Single partition means everything goes in there, is side by side. Multiple partitions means ada kat atas, ada kat bawah. That means, let's say proses tu namanya proses A. So proses A1 ada kat atas, proses A2 ada kat bawah. What does that mean? That means ada data di bahagian atas, ada data kat bahagian bawah. Okay, that is multiple partition. Or it can be in a single partition. Means semua proses tu semua dalam RAM. Okay, it can be in that way. Or it can be in the paging and segmentation. We'll do this in the next class. Okay, so contiguous means it's like this. So this is an example of your operating system. The top part, we say the low memory, because the address starts at 0, is where the operating system file sits. Sampai habis, you on your PC, until your PC shuts down, the operating system file sits there. This location here is given to process. So this is called the fixed size diagram, and the files are all contiguous. Okay. So how much need it be given? Depending. Kalau size dia besar tu lah dibagi. If the size of the process is 30 kilobyte, then you will get a location of 30 kilobyte. Okay, so single partition, only one process in the memory at one time. One process. Okay, one process. What does that mean, one process? Let's say you have a process, size dia ialah 100. Tapi bila dia masuk dalam memory, only one chunk or one part of it. Okay, ada proses lain masuk. Okay, so in this format, you can see that each process inside the memory goes in by chunks. Okay, dia akan masuk satu saja. Okay, that means 5 here. Mungkin ada lain pasal 5 ni, tapi each time dia masuk satu. Okay, so before this diagram, we have a big hole. You see, we have a big hole. It's a block of available memories. Okay, so their size dia. So dia masuklah, kalau proses 5 dia nak 10 kilobyte, masuk je. As long as there is an empty space. Okay, so this is what we say as a multiple partition allocation. So there are two versions, fixed and dynamic. Fixed means the size here is fixed, and dynamic means the size is macam ni, ada yang besar, ada yang kecil, ada yang besar, ada yang kecil. Okay, in a fixed size partition, okay, the operating system, the RAM is divided into fixed size. Nampak ni? Fixed. Semua ni sama je. Alright. So let's take this example. Let's say inside your memory, each fixed size is 8 megabyte. And you have a process A. Process A, size dia ialah, let's say, 8 megabyte. So it gets one location. If the size is 16, it gets 2 location. If the size is, let's say, 17, how many location does it take? It takes 8, and 8 is 16, tak cukup lagi because it's 17, it gets 3 locations. However, there is a balance sebab 3 ni, 8 times 3 is 24. The process only uses 17. So there is a balance of 7 megabyte, which is unutilized. This 7 megabyte space, which is unutilized, is what we say as a internal fragmentation. Internal fragmentation is an empty spot inside the fixed location, which is unutilized. Okay. All right. Let's say we go for the unequal size. Unequal size, that means if the process needs 6, you get 6. 16, you get 16. 13, 5, 8, so on and so forth. Okay. Let's assume after a certain period of time, proses yang ni habis, 5 ni habis, and 6 ni habis. So there is a balance of 11 megabyte. This 11 megabyte is what we refer as external fragmentation. It's an empty space outside those fragments. Why do we call it external fragmentation? Because let us say there is a process coming in. Okay, process B pula. And the size of process B is 10 megabyte. It cannot go in here because sini tak cukup, sini tak cukup. But if you combine these two empty spaces, which is 11, then this process can go in. Okay, so this, but it's not combined yet. So this uncombined space is called as external fragmentation, an empty space which is outside the block. And there is a method by the operating system in order to solve this external fragmentation. So external fragmentation, okay, this is internal fragmentation. It's an empty space within the process. Nampak ni? Nampak ni? Okay, it's unused. All right. So external fragmentation. So this is okay. So external fragmentation is something like this. These are all outside, and we have a method called compaction. What does compaction do? Compaction is basically to reorganize these empty spots here and include them and plus them all together so that all the empty spots will be at the bottom of the memory. Okay, will be bottom of memory. All right. So based on this diagram, let's say there is a new process coming in. Okay. Let's say the new process which comes in is process 5. Okay, let's say process 5. And this process is only 80 kilobyte. So 80 kilobyte can go here, and can go here. All right. But which location does it go? So operating system has a algorithm which is called first fit, best fit, next fit, worst fit. First fit means it looks through at the biggest hole it can find. From top to bottom, dia akan cari ruangan kosong yang paling besar. Best fit, it will look for the best or the smallest hole. That means yang ruangan yang cukup makan dia. Or next fit, it will look at where was the last input and then it will start from there ke bawah. And worst fit is the biggest hole which is available. Okay, so if the process is now 80 kilobyte, kalau kita guna teknik first fit, that means dia akan check from top to bottom. Ruangan kosong yang pertama dijumpa, dia akan masukkan. So 96, so that is the first one. So in first fit algorithm, 80 kilobytes will go inside. If best fit algorithm, from the top to the bottom, it will look for the best cukup makan. Oh, was it 80 or was it 60? Sorry, it was 60. Okay, so I repeat. So 60 kan? So kalau 60, it will look from top to bottom. In the first fit algorithm, it will check the first one it finds, which is the first one, which is this one. So 60 ni akan masuk. If the best fit, it will check for the empty space, which is the best for it. It means there is small internal fragmentation. So they will check top to bottom. 64 cukup untuk dia. So dia masuk. Next fit ialah they will look at kat mana proses sebelum ini berhenti. And from there, they can tengok ke bawah. Let's assume that proses sebelum ini berhenti di sini. So daripada sini, they can tengok ke bawah. Okay, kalau next fit, let's say the last process was this one, or this one, the last process like katakan sini, then they can tengok dari sini ke bawah. ruangan kosong pertama yang dijumpa. So it will be 96 as well. Okay, or the worst fit, the biggest ruangan kosong yang dijumpa, dia akan masukkan top to bottom. Alright, so the biggest is still 96, so dia akan masukkan process to the center. Okay, so that is first fit, best fit, next fit, and worst fit. Okay, so you can read this on your own. And we also have another way of solving the external fragmentation, which is called paging. Okay, so we will do paging in the next class. Okay, so this is how compaction will look like. These are empty spots here. When we do compaction, kita akan susun balik so that all the empty spots come down here. Okay, empty spots come down here. This is how you want to solve external fragmentation. Sorry. All right. So this is how we want to solve another external fragmentation using paging method. Okay. All right. I will stop here because this chapter is a bit heavy. So we will stop at slide number 33, and we will continue another 30 more slides in the next class. Okay. All right. Do you have any?
Okay.
You have any questions to ask me?
No, sir.
Okay, so make sure you sign your attendance, and I'll see you next class. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Thank you, sir.